Good afternoon, girls. So, in the last class, we were talking about the introduction to data warehousing, and we have also discussed what is a multidimensional data model. And when we talked about the multidimensional data model, we discussed the multidimensional data model will be represented as a data cube, and why we need it to be represented as a data cube also we discussed in the last class. Why a multiple dimensional data is to be represented as a data cube, and why we need multi-dimensional data model in a data warehouse. And we have seen our traditional data queries, you call it as SQL queries. These SQL queries are very difficult, and it becomes very complex when you need to analyze on multiple dimensions. Suppose you want to take the sales report to be analyzed based on the salesperson, based on the region, based on the time, based on the location, based on the item. Like that, if you start adding more dimensions, it is going to become very difficult. And not only difficult, it becomes a very complex when you start writing the queries in your traditional data model. So that is why we always prefer multidimensional data model in the data warehouse. And not only that, the data warehouse will be using multidimensional data model, but this data model will be represented as a data cube for the analysis. Now, whenever I am going to call a data cube or a multidimensional data model being used in the data warehouse, obviously the data inside this multidimensional data model will be viewed as lattice of data cubes. We have already seen in the last class what do you mean by lattice of data cube. So this diagram we have already seen, and we have seen what do you mean by apex cuboid and what do you mean by base cuboid. Apart from that, each dimension cuboid also we have discussed. The same diagram we have discussed in the previous session also, right? So whenever you are going to have a multidimensional data, it will be having a base cuboid, and the base cuboid will be represented like this. Cuboid C and A1, A2, AN are the different dimensions. So this base cuboid includes all the data cells, right? So this is your base cuboid, and it includes everything. All the data cells will be represented here. So it includes everything, all the 4 different dimensions. That is what the example shows here. So all the 4 different dimensions will be included here. It includes all the data cells, and all the n-1 dimension cubes are obtained by grouping the cells, right? And not only that, you will be grouping the cells. Along with the grouping, you will be computing the measures also, right? So when I say grouping, say for example, if I want to have 2 dimensions, I will be grouping 2 different dimensions. What are the 2 dimensions I am grouping here? I am grouping time and item. So when I am combining time and item, you are not only grouping them, but you are also going to compute the combinations of numeric measures of a particular dimension. So say for example, if I am going to combine time and item, I will be combining the measures of 2 different dimensions. What are the 2 dimensions? Time is one dimension, item is another dimension. So for these 2 dimensions, whatever measures are available, these measures will also be combined here. Suppose if you are going to take this particular location, I am going to have 3 dimensions. What are the 3 dimensions? Time, item and location. These 3 are grouped together. Along with this grouping, you are going to have the measures being combined. What do you mean by measures being combined? You are going to combine the sales report of a particular time which is available for a particular item, which is available in a particular location. So all these three measures will be combined together. So that is what it says. The n minus 1 dimensions will be obtained by grouping the cells. Along with grouping, you will be computing the combinations of numeric measures of a different dimensions also. And the apex cuboid. What do you mean by apex cuboid? This is what you call as apex cuboid. So apex cuboid is nothing but one particular cell. So one cell is the coarsest level, right? The last granular level will be the one cell in your data cube, and this cell will be consisting of the measures of all the n dimensions. This is what you call as apex cuboid. So apex cuboid is nothing but this particular point, and here you are going to have all the n dimensions, right? All the n dimensions which will be taken into the granular level. So when I say granular level, it will be representing only one cell. So here you are going to have only one cell information. Then when you come to the next level, you will have one dimension. When you come to the next level, you will have two dimensions, and here you are going to have three dimensions, and here you are going to have all the n dimensions. So this is how the lattice of cuboids are arranged in the multidimensional data model. So we start with granular level or coarsest level. What is the coarsest level? One particular cell in the data cube, right? Only one cell. If you take just one cell from the data cube, it becomes the apex cuboid, right? And now when you combine this one cell, and if you take one complete row or one complete column in the data cube, then it becomes one particular dimensions. When you take one column and one row in the data cube, then it becomes two dimensions. When you take one column, one row and one depth, all the three dimensions will be combined together. Then after the three dimensions, from the fourth dimensions onwards, you will start combining more data cubes for your multi-dimensional data model. So that becomes the base cuboid. So if you take only one cell, it is the apex cuboid, and if you are going to have n dimensions, then it becomes the base cuboid. So that is what is represented as a lattice of data cube. Now when you take the lattice of data cube or your multidimensional data model, we have already seen the dimensions can also be represented as a hierarchical model. So whenever you have hierarchical, say for example, if I am going to take region as one dimension, this region itself can become different levels. So you may be starting with country as a region. Then inside the country, you may have another parts of the country. Say for example, if you take India, then you can have different regions, southern region, northern region, western region, like that. You can have different regions for the country, and in each region you can have different cities also, or different states. If you want, you can represent like that. It is up to the designer how you are going to design the different hierarchical level. Then in each city I can have different offices. So this is different hierarchy that I am going to specify for a particular dimension. You call it as hierarchical dimension modeling. Or suppose if you take time as a dimension, you can start with year, quarter, month, week and day. Or if you take product, then again product can also be industry level product, and from the industry level product you can categorize them based on categories. Then under each category you may have different products also. So if you are going to have lattice of cubes which are representing n dimensions, not only dimensions are represented, the dimensions can also be further put into different levels. You call it as dimension hierarchy. So any lattice of data cubes may represent the hierarchy also. So in the hierarchy you can have summarization, or you call it as hierarchical summarization path. Now suppose if you are going to have a hierarchy like this, you can have office wise summary. Suppose, say for example, I have city 1 and city 2, and in city 1 I have 3 offices, and in city 2 I have 2 offices, right? So totally I have 5 different offices, right, in city 1 and city 2. So when you are having the hierarchical summary path, you can have sales summary of 5 different offices, 5 different office. So for each office I can have the summary. So that will be represented here. Suppose I am going to have the hierarchy in the city level. So what you have to do? You should have the sales report of all the 3 offices combined together for city 1, and the other 2 offices combined together for city 2. So summary will be reduced there. So for city 1 I will have one summary. What is that summary? Total of office 1, office 2 and office 3. And for city 2 again I will have total of office 1 and office 2, because city 1 has 3 offices, city 2 has only 2 offices. Again, if you are in one region, if I am going to have more than one city, then combine the summary of all the cities together to represent one particular region. So like that, the summary path will also be differing when you are going to have the dimension hierarchy. So that is what is represented here. Then whenever you are going to have lattice of cubes at the cell level, you will not have anything, 0 dimension, you call it a 0 dimension. Then above the 0 dimension you will have 1 dimension. Above the 1 dimension you will have 2 dimensions. Above the 2 dimension you will have 3 dimensions. This is what you call as cube lattice, right? 0 level, which you will have each cell, coarsest level or you granular level. Then 1 dimension, 2 dimensions. How do you get the 2 dimensions? Combining dimension 1 and dimension 2. Combining dimension 2 and dimension 3. Combining dimension 1 and dimension 3 here. So these are the 3 things that you will have for the 2 dimensions. Now when you take 3 dimensions, all the 3 will be combined together. You call it as 3 dimensions, right? Now whenever I am going to have cube lattice, all these questions can be answered easily. One thing, which group by to materialize, right? How you are going to group them together. Suppose if you are going to have 6 dimensions, how you are going to combine them. It doesn't mean that you have to combine all these things together, right? So it is up to the designer what are the dimensions to be combined. Now how index must be created, right? So whether you want to have AB, AC, BC, or you want to have only AB and BC, that can also be decided. Then how to organize the data. So when I am having 10 different dimensions for my data, what are the different dimensions you are going to combine them together, how you are going to create it as a chunk, or whether you are going to create it as a partition, whether you are going to create it as a segment. So how do you organize the data in the multidimensional data model should also be represented, right? So we are not going to discuss now here how to represent the multidimensional data model as a data cube. We will be talking about all the answers for these questions when we talk about the multidimensional data model, the different schemas, right? What are the different schemas that are used for multidimensional data model? So by the time all these questions will be answered, how you are going to group them together, how you represent the fact table, how you represent the dimension table, what are the different schemas used. When I say schemas, how do you design the table relationship? All these things we will be discussing in the multidimensional data model schema, or it is otherwise called as data warehouse schema. Okay, so this is what we discuss about the lattice of data cube. Now, whenever we are going to have the multidimensional data which is represented as a data cube, these are the different components that are coming in the multidimensional data model. So far we have just seen what is a multidimensional data model and why we use data cube as a representation. Then when I have data cube, how the dimensions are being combined, which is called as a lattice of data cube, etc. Now the next question is, what are the different components that I am going to have in a multidimensional data model? So whenever you have a multidimensional data model, these are the 4 components we should have in the data model. What are the 4 components? One is a summary measure. The other, please note the spelling here, it is MEASURE. Yes. Summary measures, summary function, then dimension hierarchy. So for any multidimensional data model, these are the 4 different components that are required. Now, we have already seen what is a dimension. We have also seen what is a dimension hierarchy. So you can decide. Suppose if you want to analyze on sales, you have to decide what are the different dimensions you are going to take for analyzing sales. If you want to analyze pass percentage of a particular university, you have to decide what are the different dimensions I am going to take to analyze the pass percentage of the Kannur University. Or you want to analyze the admission record of a particular university, then you have to decide what are the different dimensions I am going to take for analyzing the admission record, right? So that is what you mean by dimension here. So we have already seen, right, some of the examples we have seen what are the different dimensions used there, and there itself we have seen what is the purpose of having the hierarchy in the dimension. So if you take year, then the different hierarchy is required or not, that can be decided by the designer. Or if you are going to take a region, the designer can decide what are the different hierarchy you are going to take for a particular region. So whether you want to take the analysis up to the city level or up to the office level, or you are going to have the analysis up to the region level. So it depends on what kind of analysis is required for the multidimensional data. So based on that, you can decide the dimension and you can decide the dimension hierarchy also. Now whatever is the dimension and whatever is the dimension hierarchy, the next question is, what are the different summary measures that you can have and what are the different summary functions you can have. So summary measure is the main theme for the model. Now please recollect, up in the multidimensional data model we have seen, apart from the dimension and dimension table, we use another concept which you call as the central theme, or you call it as subject of the multidimensional data model. And this subject or the theme will be represented as a fact in your multidimensional data model, and this fact is represented as a fact table, that also we have seen. Okay, now in the summary measure, the whatever is your theme, say for example I am going to have sales as the theme, then your summary measure becomes the sales value. Whether the sales is represented in units, then the sales unit become the summary measure. Or if you are going to represent sales in amount, what is the amount of sales happened in a particular item, then the amount becomes the summary measure. So your theme is sales, whether the theme, the sales ഇപ്പം എത്ര ടി വി സെയിൽ ഔട്ട് ആയി ഒരു പർട്ടിക്കുലർ റീജിയനിൽ അല്ലെങ്കിൽ ഒരു പർട്ടിക്കുലർ ഷോപ്പ് എന്ന് ലെറ്റസ് അസ്യൂം ദാറ്റ് ഹൗ മെനി സോനി ടി വി ഹാസ് ബീൻ സോൾഡ് ഫ്രം ദിസ് പർട്ടിക്കുലർ ഷോപ്പ്. So that specifies number of units. Whereas what is the total amount of sales happened for TV? Then the amount will be represented in rupees or in dollars. I think I make sense. So based on the theme, you are going to decide how the theme will be represented. That is what you call as the summary measure. So to be more precise, a measure is nothing but aggregation of the values corresponding to the attribute or to the dimension. What do you mean by aggregation of the value? Aggregation of the value means sales report happened for TV item. അങ്ങനെ പറഞ്ഞിട്ടുണ്ടെങ്കിൽ you have many different TV items available in the shop. For all these TV items, you need one measure. What is that measure? What is the total amount happened for a particular TV item? അപ്പോൾ total amount എന്ന് പറയുന്നതാണ് we call it as aggregation of values. So this aggregation of value will be corresponding to a particular attribute. What is the attribute I have taken here now? The item sold. Item is the attribute, or the attribute is otherwise called as dimension. So in lattice of data cubes also we are going to represent here in this item what is the total sales happened for a particular item. That is what is represented here. So this is what is called as measure. So in your multidimensional data model, apart from the dimension and dimension hierarchy, one very important concept is what is the theme you are going to take for the multidimensional data model. Say the theme is sales. And in sales, how do you represent the aggregate value? How do you represent here? Maybe in number of units sold, or maybe the total amount you collect for that particular item. Like that you can define a measure also, which will be based on a attribute or a dimension. So that is what you call a summary measure. So summary measure is an aggregation of value that is corresponding to the attribute or to a particular dimension, and this will be generally based on the main theme of multidimensional data model. But say for example, for the Kannur University, if you want to have the analysis, you can have different analysis. Maybe you will be doing analysis based on the admission record. So that means the theme for your data warehouse becomes admission record. Or if you want to do the pass percentage, then the theme for the a data model will become the pass percentage. But what you are going to do in one data warehouse itself, I will have data based on the admission record, and I will have data based on the pass percentage. So this becomes one data warehouse, and the pass percentage becomes one data warehouse, and the admission record becomes another data warehouse, right? And whenever I am going to have the summary measure will be generally categorized based on the aggregate function. Any summary measure, whatever value you are going to, it is going to be the aggregation of values. It is not going to be a single value, it is going to be aggregation of values. What do you mean by that? Nariya values na combine cheynadanu, we call it as aggregation. Aggregation is nothing but combination. So how do you combine them together? The combining, right? How do you combine the different values is based on the aggregate function that you are going to have. So your summary measure can be a total, summary measure may be an average, or summary measure may be percentage. For pass percentage, I may be saying that the pass percentage for a particular course is 60%. You can represent like that, right? So that becomes one aggregate function. Or you may be specifying it like out of 200 students appeared for the examination, 188 students have passed. Then here you are not representing the data as percentage. Instead you are representing the data as total number of students passed. But total number of students become the aggregate function. So your measure will be based on what kind of function that you are going to use. Now, this function can be categorized as a distributive function, algebraic function, or holistic function. So, these are the three categories based on which the summary measure can be decided. Now, let us see what is distributive. So, distributive is nothing but if the value can be computed in a distributive manner or in a distributed manner, then you call it as distributive function. Please note, if the value can be computed in a distributed manner, then it is called as distributive function. How can you compute it in a distributed manner? The data can be partitioned into different sets. If your data can be partitioned into different sets, then you can go for distributive function. But say for example, you want to have the total pass percentage. What do? You are going to distribute it. How do you distribute it? You are going to distribute the course wise distribution you are going to do, or year wise distribution you are going to do. So your entire data can be partitioned into different set. I will be calculating the pass percentage of 2019, 2020, 2017, 2018, like that I am going to partition the data into different sets. Then I am going to apply the function. You call it as distributive function, right? So these function will be applied to each partition. Pass percentage you have to calculate 2019, you have to calculate 2018, you have to calculate 2020 separately, right? So this will be resulting in n aggregate values. Suppose if you are going to take years from 2015 to 2020, then what do? You are going to calculate the pass percentage of 2015, then 2016, then you are going to have 17, 18, 19, 20. So like that you will have 5 different aggregate values. Then you call it as distributive function. So the examples of distributive functions are sum function, count function, minimum, maximum. These are the distributive functions. So you take one entire data, and this data is divided into different partitions, and for each partition I can apply the same function. I will apply the pass percentage calculation again for the first set, second set, third set, fourth set. Or I will be applying the total, right, which you call a sum, right, SUM sum. So this sum, for sum again I am going to apply the sum function for partition 1, partition 2, partition 3. Then you call it as distributive function. Then the second one is called as algebraic function. Which is called as algebraic function? If the value can be computed by an algebraic function with m number of arguments, and generally m will be a positive integer, then each of the algebraic function will be obtained by applying a distributive function. Say for example, average, standard deviation, mean value. These are the different algebraic functions that we are going to have. But say for example, you want to find out the average pass percentage, right? You want to find out the average pass percentage of the last 15 years. What you are going to do? You are going to first divide the data, and you are going to apply the pass percentage function, which will be a distributive function. Correct? You will calculate the pass percentage of every year. How do you get it? You apply a distributive function. How do you apply a distributive function? You divide the entire data into different partition. 2010, 2011, 2012, like that you have divided the entire data, and for each year you have found out the partition, right? And for each partition you are going to apply a distributive function. What is the distributive function? Finding the pass percentage. Okay, so for each year you got the pass percentage. Like that you are having 10 different pass percentage value now. So 2010 to 2020, like that, right? So for each year you have got the pass percentage. Now you want to find out the average. What do you do? After applying the distributive function, now you got 10 different arguments, and for these 10 different arguments you are going to apply the average function, an algebraic function, which you call as the algebraic summary measure. Now, calculate your 10 years in the pass percentage will be added and you divide it by 10. So you get the average pass percentage. So this kind of computation is what you call as algebraic function. And the third one is called as holistic function, and this cannot be described by an algebraic expression, or it cannot be calculated in a distributive manner, because there is no algebraic function available with m arguments. Then this kind of computation is called as holistic function computation, where if you have median, mode, frequency, then for these things you don't have any algebraic function. If suppose, say for example, you want to find out the frequency of a particular student appearing for the supplementary, right? How many times a student has appeared for supplementary examination, then you call it as frequency. Or you want to find out the center value of a particular data, then it becomes the median. Or you want to count the values, right? So how many times, how many 80% are there, how many 60% are there, how many students have scored 45%, how many students have scored A grade. Like that, if you want to calculate the mode or frequency, then you have to trace through each value, only then you can get this value. So you call it as holistic function. So this holistic function, you don't have any algebraic expression for counting, number of students appeared for a particular examination. So you have to go through each student, only then you can understand how many students have appeared for a particular examination, which you call as holistic function. So what you have to understand here is, when you have the multidimensional data model, you have to decide a summary measure which will be based on the model. Summary measure is based on your it is based on the theme or subject that you are going to select. Then the summary measure can be based on any of these aggregate function. It can be a distributive function, or it can be an algebraic function, or it can be a holistic function. So these are some of the examples we have for the distributive, algebraic and holistic. For the distributive function, sum, count, minimum, maximum. And for algebraic, it can be average, standard deviation, maximum, n largest values, n smallest values, center of mass. These are things that we can calculate. We have formulas for these things. So we call it as algebraic function. Then we have the holistic aggregate function, which is nothing but frequency, median or ranking. All these things can be some of the examples of holistic function also, right? So this is how any lattice of cube which is used for representing multidimensional data model must contain these 4 different components. And the components, dimension and dimension hierarchy, we have already discussed. So here we have discussed only what do you mean by summary measure, and what are the different summary functions I can use for the summary measure, right? Remember, summary measure and summary function is separate ആയിട്ടല്ല പറയുന്നത്. ഒരു summary measure, if you want to represent in your data cube, it must be based on a summary function. So you take theme, or the theme is sales. Now the next question is, what is your summary measure? You have to decide. The summary measure is number of units sold. The theme is sales. Second one, summary measure. What is the summary measure? The summary measure is based on the theme. What is the theme? Sales. What is the summary measure? I want to have the number of units sold, total number of units sold for a particular item. So that is how I am going to connect the theme and the summary measure. Now since I am going to take the summary measure as number of units, what is the function you have to apply? You have to apply totaling function. Totaling function is based on the distributive function. So your theme, and based on the theme select the summary measure. Based on the summary measure you go and select the aggregate function. And it is also this way. Whatever aggregate function you are going to use, based on that you decide the summary measure, and whatever is the summary measure you have, it is completely based on the theme that you are going to select for the multidimensional data model, right? So these are some of the examples of it. Okay, so next we are going to talk about the OLAP operations.